This is Lab 5 Part 2. So I would like to explain you about the experiments in the second half, and we are going to start with the IEEE 754 single precision only. Okay, and please click on the link for you to do the arithmetic, and this button, okay, correspond to the single precision. It's 32 bits. You can also find other buttons. So this one correspond to the double precision, and this is going to be the floating point, 16-bit floating point. Okay, so let's focus on the 32-bit first. So enter -123 on the upper left text box and enter 123.0 in the next text box and press the plus button or the add button. So you will see the result here, -128 plus -123 plus 123. So you click the add button here. Okay, so minus will be converted from base 10 to base 2. Okay, so base 2 on the right hand side correspond to the IEEE 754 format that I just mentioned in the clips. Okay, and the lower part correspond to the base 16 and the base 2. Okay, 0B correspond to base 2, 0X base 16. Okay, so when you click the add button, you should get 0 as base 10, and you should get true 0 as I mentioned, okay, for IEEE 754 standard. Okay, then you can do it by hand. Okay, you can do it by hand like this to understand how 123 base 10 correspond to 42F6 000 base 16. Okay, so look at this as the E by S. Okay, E by S, it's 127. Alright, look at this as the hidden one that you ignore or you can neglect. Okay, but look at this as a normalized number. Okay, in other words, it corresponds to 1 plus this, and remember we call this part significant. Alright, so now do it by hand. Convert -123 to the binary and hexadecimal. Okay, and what about 0.0? Okay, next is the multiplication button. Okay, we are going to multiply -123 with plus 123. So what should you get? This number. Okay, and for the F floating point ALU is going to give you 0x C6 6C C4 6400 base 16. Okay, now it's time for you to convert it by hand as well. Alright, so in our exercise you need another web page, okay, to show you how to convert it easily, but more and more and easy to understand, okay. So this part is named fraction, if you recall. So he calls the author of this web page calls it mantissa. That's correspond to fraction, okay. And the exponent is 8 bits here, and the side bit here, and the fraction is 23 bits for single precision, okay. So you can type in whatever you like here, or you can check or uncheck these boxes or these bits. Alright, now let's do the exercise. Okay, enter 0.0 in the here decimal representation. Sometimes this box can be input and can be output as well. Okay, so be careful when you enter the box, enter the number. So what value actually store in float? What error due to the conversion? So please read and take notes. All right, fill up the space like this. Now put minus 0.0. Okay. Oops, sorry. Put minus 0.0. So take note. What should it be here? Now enter 1 base 10. Okay, do not put the base. Just put just 1. Alright. In the text box and hit enter. Fill up the blanks. What should 1 be in IEEE single precision? Now enter minus 1.5 and what should the numbers are? What should the numbers be? Alright. Now enter in item number 5 3.40 E38. Okay, be careful, this is the capital E in decimal text box and hit enter. So we are trying to convert this number to the maximum number. What should that be? What should it be? Okay, and answer Y as well. Okay, look at the difference. E38, is it the same as 10 to the 38? Okay, is it the same? Yes or no? And why? Okay, so be careful. Now enter minus 3.0 again. This time is the negative side of E39. Okay, what should this number be in IEEE? Alright, and should the minus infinity be? Is it a negative infinity according to the table that I mentioned, 5 possibilities? Okay, and number 7, enter this E minus 38. Okay, and fill up the blanks and answer, is it normalized or denormalized number? Okay, and next enter 5.8 E minus 39. Okay, and take notes and answer why. Is it denormalized or normalized? Okay, so we will do a lot in this lab 5 part 2. Now, item number 9. Now it's time for you to experience NaN or not a number. Okay, so put the check and uncheck boxes to get a NaN representation. Okay, what should the decimal number representation, and so on. Copy item number 10. Copy the 32-bit binary number NaN. Copy the NaN that you obtained from the previous activity. Paste it in the binary section of the following link. We want you to convert a NaN of this IEEE to be the integer size. Okay, size integer. And are they the same? Press convert and capture the screen here and put it here and explain why it is an integer, not a NaN. Okay, so it's just the interpretation that, oh, this number belongs to IEEE, we call it a NaN. If this number is a size integer, what should that number be? Okay, so it's just a different interpretation. The last experiment is about the character code. Okay, so we want you to open up this web page. It's the it's a ASCII converter. Okay, copy these characters and paste into the ASCII input box. Okay, so you can see that these are Thai characters followed by A, B, C. Okay, we call it สระไอทอทหารยอยักษ์กอไก่ขอไข่ Okay, and we have some space in between. Okay, some space. All right, and take the note like this. Okay, so once you copy it, you click convert to see the outputs and answer the question. Try to, you can remove the 0x. Okay, you can visualize these numbers in decimal. Okay, you can visualize these numbers in binary and base 64 as well. Okay, so for this part, do exercise 3 only. Okay, only. Okay, and try to answer UTF-8. What is UTF-8 and why? Okay, thank you very much.